YouTube, in this video we're going to show how you can write the equation of a parabola given some information about the parabola. Okay, we're going to go ahead and read through what we have written here. It says write the equation of the parabola that has a vertex of -4, 11 and goes through the point -6, 15. Okay, so the things we want to kind of point out here are these. We've already been given some information here. We know that this one right here is the vertex. So the thing that's nice about this is that we kind of already know a little bit about our equation, okay? And then they also gave us some x and some y that are on the curve, okay? So now the nice thing is they could have given us any point on the curve, but we just need one. Real quick before we write this equation, let's go ahead and review. When we talk about a quadratic function, we say that it is something that is of this form, where a does not equal 0, but we could also write it in what we call vertex form, where vertex form is what we're used to seeing is this quantity right here. Okay, and so what we know about this is that the vertex, of course, the vertex is at h and k, and the axis of symmetry, so the axis of symmetry, we know is that x equals h if it is written in what we call standard form. So here's the deal. I want to use this right here to work backwards to find the equation. And to be real honest with you, what they've already done is they've told us the vertex. So we know h and k. We know h and k right here. So we say h comma k, the vertex, is really at -4 comma 11. So we have h and k. And then we say we have some point xy on our curve here. We say this is -6 comma 15, some x, y. So when I look at this equation over here, what I want to kind of do is this. I just want to go ahead and substitute. And what I'm doing is I'm substituting all of the values I know and going and searching for the ones I don't know. And so notice that I know x and y. I know x is right here. Y is technically over here for f of x. And then h and k, we know h and we know k as well. So the only thing that's lacking here is a. So to write this equation, let's just go ahead and plug in what we know. So we have y equals a times x minus h squared plus k. And I think that it is helpful for sometimes, for people to write these things underneath. We're just going to put things where they go. So for instance, our y value of our point that was the solution is 15. Our x value here is -6. Okay, we have an h value of -4. And we have a k value of 11. So what we're going to do now is we're going to go through and simplify this and solve for a. So we'd have 15 equals a. Now in parentheses we have -6 minus a -4 is plus a +4, so we get -2 squared plus 11. Simplifying this further, we get 15 equals a times 4. So we could really write this as 4a plus 11. When we take away 11 from both sides, we're going to get left with 4 equals 4a. So what this means is that our a value, and this is all we wanted to find because we wanted to find the equation, is equal to 1. So are we done? Okay. What we wanted was the equation. And when you talk about an equation, we say it's y equals a times some x minus h squared plus k. Okay, now we have h and k. We had h and k. I can even go put these in now. We say -4 and we say 11 here. But the thing we didn't have, which we do have now, is 1. So the equation of this parabola would be this: x plus a +4 squared plus 11. Okay, and this would have a 1 in front. And just to go to show this, I mean, if we were to sketch this, I suppose what we're saying is this: -6 comma 15, 1, 2, 3, 4, 5. -6 comma, let's just talk about this. This would have a vertex that would be -4 comma 11, and this was told to us right off the bat. So if we went left 4 and then up 11, we'd be somewhere like up here. Okay, and our a value is 1, so I know that this opens up. But all I'm trying to say is that it'd be perfectly reasonable to think if this is -4 and this is -6 here, that this point -6 comma 15 was actually on the graph. Okay, so this is a nice way to be able to write the equation.